area of a surface of revolution, we derive the formula for the surface of revolution s equals 2 pi, the integral from a to b, f of x, the square root of 1 plus f prime of x squared dx, where the radius of revolution is y or f of x, and the arc length differential is ds. For example, confirm that the surface area of a sphere of radius r is 4 pi r squared. The equation of the circle is x squared plus y squared equals r squared, and so y equals plus or minus the square root of r squared minus x squared. The positive piece is the upper curve. Using the arc length formula, f of x is y equals the square root of r squared minus x squared. F prime of x is 1 over 2 the square root of r squared minus x squared times minus 2x using the chain rule. In the arc length formula, we would need to square f prime of x. So to simplify f prime of x, we end up with negative x over the square root of r squared minus x squared. F prime of x squared is therefore x squared over r squared minus x squared. In the area of the surface of revolution, we need to add 1 to the square root of f prime of x. This is 1 plus x squared over r squared minus x squared. Combine the two terms. The common denominator is r squared minus x squared. The numerator is r squared minus x squared plus x squared, which is r squared over r squared minus x squared. S equals the integral from a to b, where a is negative r and b is capital R. The radius of revolution is y equals f of x, but y is the square root of r squared minus x squared. The differential arc length is the square root of 1 plus f prime of x squared, which is the square root of r squared over r squared minus x squared dx. Simplifying this, we have 2 times the integral from 0 to r 2 pi r times dx by symmetry. This is 4 pi r, the integral from 0 to r dx. This is 4 pi r times x evaluated at 0 to r, or simply 4 pi r squared. This is the surface area of a sphere of radius r.